Hello, my name is Jeff Hensler, and this problem is for microeconomics with Miss Julie Cantrell. I'm doing question 14 off of the Chapter 4 test, so we'll get started. Question goes, 3 workers at a fast food restaurant pack the takeout chicken dinners. John packs 45% of the dinners but fails to include a salt packet 4% of the time. Mary packs 25% of the dinners but omits the salt 2% of the time. Sue packs 30% of the dinners but fails to omit the salt 3% of the time. You have purchased a dinner and there is no salt. So part A of the problem and part B are both pretty much the same question, just asking for Mary's and John's the probability that John packed her dinner or that Mary packed her dinner. So first step would be, this is Bayes' theorem, by the way. First step would be to create a tree diagram. I recommend as the easiest way. So to do that, I labeled John, Mary, and Sue, each branching out. Oh, great. Not working here, so use the red one. I use John, Mary, and Sue as probabilities. This is the probability. This is the percent that of the dinners that each of these people pack. So John packs 45%, Mary packs 25%, and Sue packs 30% of the chicken dinners. Now, when John packs a dinner, it says that he forgets to include the salt 4% of the time. So after he packs a dinner, 4% of John's dinners will not have salt because he forgot. And this 96%, he's cool and he doesn't forget. So same with Mary. She packs all of the dinners 25% of the time, and 2% of the time she forgets to put salt in. So 98% of the time, Mary dinners are good. And finally, Sue, she packs 30% of the dinners and forgets to include salt 3% of the time. So how do we find the answer to these questions? Find the probability that John packed your dinner. We don't have salt, so given that information and the tree diagram, we can figure this out. So what we're going to do then here is, Bayes' theorem says that we have to take this, we have to multiply these two values, the probabilities, the 0.45 and the 0.04 together to get the percentage that John packs dinners without salt. So 0.45 times 0.04, oh, I already did the math. 0.45 times 0.04 gives us 0.018. We do that for each of these people to find the percentage of time that their meals don't have salt in them. So what we do is we take 0.45 times 0.04, or 0.45 and 0.04, gives us 0.018. We divide that number by the sum of all 3 percentages that we have from the diagram of John, Mary, and Sue. So I did the math for that as well, and that equals out to 0.018 divided by 0.018 plus 0.005 plus 0.009. I apologize, my marker isn't very good, and these are all that I got, so I'm doing what I can. These 3 add up to 0.032. The final answer is 0.562. 0.5625. So, next part B, find the probability that Mary packed your dinner. To do that, we just kind of do the same thing. the Mary's probability that they're salt in the meal is 0.005. So we take that value, there we go, 0.005, and we divide it by the sum of all three outcomes. So 0.018, it was the same as before, 0.018, 0.005 plus 0.009, which is 0.032. That equals, when you put it in your calculator, class, 0.1563. Final answer, Bayes' theorem. Thank you very much.